Hello everyone and welcome back. In this lesson, we are going to learn how to automate the linking of nested family parameters with the host family parameters using the Revit API. Often in Revit, we work with families that are built using nested components. These nested families might contain their own parameters which control the geometry or behavior of the form. However, unless we link those parameters to the host family, we cannot control them from the top level. And doing that manually can be time consuming, especially when dealing with complex nested families. To automate this process, we will follow two simple steps. First, we will extract the parameters from both the host and nested families using the query parameters and query element parameters components. Then we will use a Revit API method, associate element parameter to family parameter, to create a direct link between them, allowing the host family to drive the nested geometry. Let us take a closer look at the method we are going to use in this workflow. The associate element parameter to family parameter method is part of the family manager class in the Revit API. It associates or disassociates the element parameter to an existing family parameter. This method creates or removes a parametric link between a parameter from a nested family element and a parameter defined in the host family. This allows the host parameter to drive the value of the nested one directly. This method accepts two inputs. The first input is called element parameter. This refers to a parameter on a nested family element that has been placed inside the host family. It could come from a nested instance or a nested type that is actively being used within the host family. The second input is family parameter. This is the parameter defined at the host family level, the one that we want to use to control the nested family parameter value. When both parameters are valid and have the same data type, the API creates an internal association. This means any change made to the host parameter will automatically update the nested parameter as well, ensuring full parametric control. If instead we want to remove this association, we can pass none as the second input. This will disconnect the nested parameter from the host and allow manual edits again. There are two important conditions to keep in mind while using this method. First, both parameters must share the same parameter type. If the host parameter is a length, then the nested one must also be a length. Otherwise, Revit will throw an error and the transaction will fail. Second, the nested parameter must belong to an element that is actually placed inside the family. We cannot associate parameters from a type that is not instantiated. The nested type must already exist in the family environment. With that method understood, let us now look at the families involved in this setup. Here we have the host family, which is created using the structural framing family template. Inside this family, we have placed a nested component, a T-beam profile. If we open the type properties of the nested family, we can see that several parameters are defined to control the geometry of the profile. At the moment, these parameters are not linked to anything. They are free and cannot be controlled directly from the host family. However, if we look at the host family's type properties, we can see that we have already created corresponding parameters that are meant to control the beam. Using the Revit API, we will now link these host parameters to the ones in the nested family. This will allow us to drive the nested geometry directly from the host family's type properties. Let us now move to the Grasshopper definition that drives this process. Our main task here is to get the parameters from both the host family and the nested family and then connect them using the Revit API. For the host family parameters, we use the query parameters component. We connect the family document as input and set the scope to type. This ensures that only type parameters from the host family are extracted. Next, we need to get the parameters of the nested family. To do that, we first select the nested family type, then use the query element parameters component. We filter the parameters under the dimensions group because these are the ones we intend to control. We then use the parameter identity component to extract the names of the parameters so that we can reference them later in the script. It is very important to maintain the order and sequence of parameters in both families. The script is designed to work based on index matching, meaning the first parameter in the host list must correspond to the first parameter in the nested list. If the host family has width as the first parameter, then the first in the nested family should also be width to ensure correct linking. In our case, both families were created with the same parameter creation order, so the sequences already match. But if that is not the case, we can use the inspect element parameter component and manually reorder the parameter list using merge or entwine components in Grasshopper. This gives us full control over how parameters are matched before they are linked. Now, before we dive into the Python script, let us briefly review the inputs for this component. The run input is a toggle to control when the script executes. FamilyDoc is the active family document where the parameters will be linked. Host family and nested family param are the two parameter sets to be connected. And nested family is the family type instance that is placed inside the host. With all the inputs prepared, let us now walk through the script that performs the linking. We start by accessing the family manager from the active family document. Along with that, we define an empty list called results. This list will store the messages from our linking process so we can track which parameters have been successfully connected. Then we check if the run input is true. If not, the script exits without doing anything. Next, we extract all parameter names from the host family input and store them in a list. Then we loop through those names and use the family manager's getParameter method to retrieve the actual family parameter objects. These will be used for linking. If you are wondering why we need to do this step again, even though we already extracted the host parameters earlier, we discussed this in a previous lesson. It is necessary to resolve the parameters into proper family parameter objects before we can associate them. Once we have the host parameters ready, we begin a transaction inside the family document. We start a loop that goes through each parameter name from the nested family. For every step in this loop, we extract the name of the current nested parameter. At the same time, we also retrieve the corresponding host parameter from our previously collected list. This one-to-one mapping is based on order. That means the first nested parameter links to the first host parameter, the second links to the second, and so on. That is why it is important that both lists are arranged in the same sequence. Next, we go through each nested family instance that has been placed in the host family. For each one, we use the lookup parameter method to find the matching parameter by name. If that parameter is found, we associate it with the host parameter using the associate element parameter to family parameter method. This creates a direct link between them, and every time a link is made, we store a small success message in the results list so we can see which parameters were connected. After completing the loop, the transaction is committed and the link is established. The script then outputs a list of messages confirming which parameters were successfully linked. Now let us run the script and see the results. As we can see, we get confirmation messages showing that the parameters are successfully linked. We can also open the nested family type properties in Revit and confirm that all type parameters in the nested family are now linked to their counterparts in the host. This means we can control the nested geometry directly from the host family by modifying its type parameters. This workflow gives us a clean and automated way to handle parameter linking, saving us from repetitive manual assignments and reducing the chances of errors. And in the same way, we can also disassociate the parameters if needed. That wraps up this lesson. Thank you for following along and see you in the next one.